Hello and welcome to ChemwithCam. The lighting in this video is going to be a bit off because I haven't got my room ready yet. You can probably tell that we're in a new room just by the fact of, how the board is oriented. But I'm still setting up the cameras and everything, but I need to get this video done and out of the road, so I'm doing this today. And hopefully the next video that I film will be also fairly decent. So last week we defined some basic terms in chemistry. So this week what we're going to do is follow that up with a definition of the states of matter. You may have heard of the three main ones: solid, liquid, and gas. These are the three main states of matter which everyone has heard of. You may also know of a fourth state of matter: plasma. Chances are you've heard of it, but you don't actually know what it is or how it relates to chemistry. But we'll cover that in a moment. If you're an avid viewer of John Lloyd's QI, hosted by Stephen Fry, you may know that there are really 6 states of matter. I'll link to the BBC video in the description where Stephen Fry actually gets this wrong and says that there are 4. But, there are actually 6, which most people wouldn't know the last 2. And they're more of a physics thing because they're not actually made of whole atoms. They're made out of subatomic particles. They are, just in case you wanted to know, Bose-Einstein condensate, which is actually a lot of what physicists call bosons altogether, and the other one is fermionic condensate. As I said, these are made of subatomic particles and are therefore not really relevant to chemistry, so I'm just going to wipe them. So what are these? How do we define these states of matter? What is our definition? A solid is something which can hold its own shape and volume regardless of the container. So for example, this eraser is solid because it doesn't conform to the shape of my hand. It's not liquid, it doesn't just magically conform to the shape of my hand. And it's a constant volume. The volume doesn't change given the container. So it's a constant shape and volume regardless of the container that it's in. This container at the moment, it's in the room. If I threw it out the window, it'd still be the same size and shape. A liquid is defined as something that holds its own volume but is always changing shape depending on the container that you put it in. Like for example, if you filled a cup with water and then poured that water into a frying pan, the frying pan and the cup are different shapes, but you're always going to have the same volume of water. Another way you can put this is that water's density remains constant given a constant temperature, and you can put water through a silly straw, and that'll change the shape. You can change the shape of the straw, you can change the shape of anything, you can change the shape of water all you want, but it won't change its volume. And that's what a liquid is. A gas is where the container dictates both the size and the volume of the substance. Like for example, you can have 1 kilogram of gas in a room, or you can have 1 kilogram of gas in a cylinder. And the room is going to be a different shape to the cylinder. It's also going to be a different size, but that kilogram of gas is going to be constant. It's the same amount of gas, it's just in a different shape and volume. So with a gas, you can change the shape and the volume of the container, and it will also change the shape and volume of the substance. A plasma, very simply, is an ionized gas. It's a gas made of the ions we discussed in my previous video. Of course, these are very simple definitions, and there are some things which don't fit these definitions. Like, for example, corn flour and water, which, when you push on it, is really solid. When you don't have too much water in it. This is fairly watery. I'm really bad at making goo. Anyway, non-Newtonian fluids like this are a completely different video. It's a whole video of its own, and I really don't have time to cover it now. So therefore, we're going to go with these simple definitions. These 4 states of matter readily change between each other. Like when you change temperature or pressure, they'll easily change between each other. When it gets hotter, it moves up this way. When it gets colder, it moves down that way. Simple. So what are these changes called? All changes between these states of matter are called phase changes. There are many different types of phase changes, given different substances and different temperatures. So the first and most obvious is moving from a solid to a liquid. Everyone knows what that's called. That's called melting. What about from a liquid to a solid? Well, what does ice do? It freezes. Same difference. So that phase change is called freezing. But what's moving from a liquid to a gas? Well, most people would call it boiling, but we've got a very specific word for it, which you would have heard if you did anything to do with the water cycle. It's evaporation. Okay, so moving from a gas to a liquid. Well, we've heard that as well when we've done the water cycle. It's fairly easy. Condensation. So what about moving from a gas to a plasma? Well, like I said before, a plasma is just an ionized gas. So moving from a gas to a plasma is going to be called ionization. Well, what about going from a plasma to a gas? If there's something called for it going one way, it's obviously got to be called the other. So what is it? Well, that's something you wouldn't quite expect. It's actually called recombination. I don't know why, and I would do more research on the topic, but I'd really like to get this video done. I apologise. So the question remains, why have I done this in a Z shape? Well, not just to conserve space, as most people would believe. There's also something quite beautiful which happens between a solid and a gas. You can skip the liquid phase entirely at the right pressures for pretty well any substance. Carbon dioxide happens to do this at atmospheric pressure, and it's actually really interesting. It's called sublimation. And while I don't have the equipment to show you this at atmospheric pressure because I don't have anything cold enough with me, going from a gas back to a solid is called deposition. So on the note of sublimation, I've got a bit of an experiment I'd like to show you. So let's just cross to our experimental correspondent, Cameron Barlin. Over to you, Cameron. We're outside right now because I've got something here that I'd like to show you which is very relevant to today's lesson. What I have in this esky is dry ice. Dry ice is solid carbon dioxide. Carbon dioxide freezes at roughly -78 degrees, and anything below -78 Celsius, carbon dioxide is solid. But anything above -78 Celsius, carbon dioxide is a gas. Why is that? Carbon dioxide at atmospheric pressure does not have a liquid state. Now that might seem a bit odd. How can something not have a liquid state? Because the bonds in a carbon dioxide molecule are so stable, there's no intermolecular forces holding the molecules together. You'll see if I hold it up to the camera. That it has this cloud-like stuff coming off it. Now that's the water in the air freezing on contact and turning into a cloud, because that's what a cloud is. It's the water vapor in the air freezing on contact with really, really cold air. And you'll see that it leaves really cold marks. It's getting smaller, but there's no liquid there whatsoever. And that's the cool thing about carbon dioxide, well, other than the fact that it's -78 degrees, that's pretty cool as well. But that's the cool thing about carbon dioxide, is that it doesn't have a liquid state. What it's doing now is sublimating, which means it's going from solid to gas without a liquid state, which is all I'm trying to show you here. Very few compounds do this at atmospheric pressure. It's actually really interesting. You see, it's still getting less and less. There looks like to be less there than there was to start with, and I'm going to keep playing with this. Now that you've seen carbon dioxide sublimate, I thought, well, while I've got this kilo bag here, I could only buy a kilo. I couldn't buy small amounts. It's really annoying. So while I've got this kilo bag here, I thought, you know what? Why don't we do something good with it? So that's what we're going to do. We've got this dry ice and we've got this esky with water in it. So let's see what happens when we put all this in here. Come on, a bit more than that. That is what happens when you put it in water. Now what's happening there is that the carbon dioxide is boiling really, really quickly. Bad idea in the wind. Anyway, the carbon dioxide is boiling in the water. And as the water warms it up, it's boiling and splashing the water around, creating a lot of small particles which then freeze and create the clouds that I was talking about earlier, only in much, much, much greater detail. I love this. It's so good. This is why I do chemistry. This is how a smoke machine works in a club normally. You put carbon dioxide into water, this happens, and then you blow it onto the dance floor, and then a lot of drunk people enjoy it. And that is the end. Please like the video, share it how you will, subscribe for more chemistry goodness. Links to the material safety data sheets for the dry ice that I used in this video will be in the description. And as always, remember, safety first.